After that we have another numerical in which a 3 meter wide and 8 meter high rectangular gate. Okay, this rectangular gate is present in that part. Okay, located at the end of the rectangular passage that is connected to a large open tank filled with water as shown here. Okay, this tank is completely filled with water, and this is a rectangular passage. Okay, with a dimension of 8 meters and 3 meters and 8 meters. Rectangular passage. Definitely, this is the 8 meter height, and the width of this passage is 3 meters. And the gate is hanging with at its bottom and held close to a horizontal force. This is the axis around which the gate rotates in that manner. Okay, this gate is may open in anti-clockwise direction around this point. This is the fixed point, and as shown in the figure, there is a force which holding this gate from the center part. What we need to determine is determine the maximum water depth H. The value of H needs to be determined above the centroid gate that can exist without the gate opening. The answer is the answer same if the gate is hanging at the top. Explain your answer. So in first part we have to resolve it in such a manner the gate open around an axis with the bottom part. You can see the black circular part. In the second part, you need to compare your answer when the gate is hanging from the top of this passage, like the axis of rotation present in that part of the gate. And here you can see this H value needs to be determined, and this is nothing, it is just the value of HC, the centroid. So we will solve this numerical using whiteboard. Okay, so let's suppose I have sketched the figure here. This is the horizontal force applying on a hold up this gate. Okay, and its direction is in opposite to the gate opening. On the other hand, the liquid applying its resultant force here with Fr. That's why we categorize this height as YR. And there is the HC, which is the height of centroid. So I have done a little bit work here in order to avoid the time wastage. Okay, I determined the area of this passage. Okay, this is nothing, 3 multiplied by 4. We know the main formula of Fr, we know the main formula of YR. And IXC value for the rectangular passage we identify from the figure, and which is coming equals to 128 m power 4. Here we will apply that the clockwise movement is equals to anti-clockwise movement. Okay, because there are two forces with two arms, like FH is multiplying applying on this surface with this complete arm. Okay, and on the other hand sorry, with this arm, which is equals to 4 meter. On the other hand, the liquid applying pressure and its arm is as the gate opening to this, we don't know, let's say this height is L here. Okay, so we can write an equation here as F H multiplied by 4 is equals to F R multiplied by F. This is our main equation, and we know the value of FH, but what's the value of FR? For that we need to determine the specific weight. Okay, the water specific weight is 9810 Newton per cubic meter. Area, we have to notify here HC value, which is still we don't know. So we reduce this equation in all the formulas, like N9 9810 multiplied by the area, which is equals to 24 multiplied by HC. Okay, and I can write all these things in this formula, so it becomes 9810 multiplied by 24. Okay, write it in that manner. 9810 multiplied by 24 multiplied by HC and F. Okay, so let's say this is our first equation. After that, we can analyze that we know that Fh is equals to multiplied by 1000 newtons. So here let's put the value of 3500 multiplied by 10 to the power 3. So this equation can be simplified that 59.4 is equals to L into HC, and this is your second equation. After that, now a close look about all these things. Okay, this is YR, this is HC, and this is your L. If I want to know the value of L, it will be equals to HC plus 4. Is the complete length here. Okay, if I add HC and 4, it will equals to the complete distance here. Okay, then I subtract YR from this so that I can easily determine what's the value of L. So here I'm going to do the similar thing. L is nothing, just equals to HC plus 4 and minus YR. So definitely there is an influence of YR value as well in this numerical. So what we do is and YR value is here. So this becomes all factor can be symbolized at HC plus 4 minus these things can be written as in the form of HC. Okay, these YC is equals to HC, so do not confuse with that. YR will be equals to, as we determine the value of IXC as well, so 128 over HC A, again minus sign with HC. If I open this bracket, what happened, this HC cancel out the HC, so the L will be equals to 4 minus 128 over HCA, and A has a value of 24, so we can write here as 24HC. Put all these factors in this equation in order to make it a univariable equation. So I just remove certain part, okay, and try to resolve the same. .46 is equals to the value of L, which is nothing, just equals to 4 minus 128 over 24 HC multiply by HC. So here you can easily identify the value of HC as so if you resolve this equation, you come up with a solution of 6 point here HC. I rub out this, okay, HC will be nothing, this equals to 16.198 meters. For part B, the case is a bit different. The similar equation will develop for part B, in which here the axis of rotation is not, it is present at the top part of the gate or the passage, and L is not present here. L is present at certain part here. Okay, so Again, we will do a similar manner like fh multiplied by 4 is equals to fr multiplied by the length. Sorry, this length will be not like that. Actually, it will be that much because this is the arm of fr about this axis. And on the other hand, fh is apply its restricting force with the centroid. Okay. So here we can comes to know that 35,000 and raised to the power 3 multiplied by 4 is equals to fr. Again, it is equals to the specific weight 9810 multiplied by the area which we have calculated is equals to 24, and the value of hc multiplied by m. So let's hold up this equation and name as equation A. Okay, we are now solving part B. Sorry for not changing its value. Now L1 is equals to I need to calculate this part. For that, what I will do is L1 will be equals to YR minus HC okay, YR is this complete length in which I have subtract HC. So now I am here in this only a very small part, and in this part I have to add this 4 meters. So I just add 4 meters here. So this is equals to. On the other hand, we have calculated the value of YR, which was equal to 128 over 24 HC plus HC minus, now this YR value is here, HC plus 4. So when we open this again, this HC will cancel out and your L1 will be equals to 128 over 24 HC plus 4. Now I just need to put this value in this equation. So 3500 10 raised to the power 3 multiplied by 4 is equals to 9810 multiplied by 24 multiplied by HC multiplied by this complete factor 128 24 HC plus 4. So I just make this equation. So we come up with this value of HC $13.532. So this is your answer. So now we move forward in our slideshows. Okay, then we have a numerical. So far we are calculating, or the case we are considering, we consider that the specific weight of the liquid throughout the storage tank or the settling tank or any tank or silos is constant, but in real cases it may vary even. If you are dealing to oil, definitely the specific gravity at the bottom part is much higher at level where the material is present at the top, because the oil, edible oil, is the composition of range of the compounds of hydrocarbons. Okay, so definitely some of the hydrocarbons have higher specific weight, some have lower specific weight. So the specific weight for that particular storage tank may vary from position to position. So similar type of case we have an open rectangular settling tank contains a liquid suspension. We have given a certain time for this, so the data they have provide us, and what we have to do is we have to determine by mean of numerical integration the magnitude and the location of the resultant force that the liquid suspension exert on the vertical wall of the tank, that is 6 meter wide, and the depth of the tank is 3.6 meters. And here is the data, and the specific weight is varying with respect to the height, or you may say that is the specific weight is a function of height here in this numerical. So just for the revision, I just write the Simpson rule here, because again we have n value of 1, 2, 3, 4, 5, 6, 7, 8, 9. N plus 1 is 10, and n divided by 3 is, so this is applicable for this case, and we have to reduce in this formula, in which x is h and f is definitely specific weight is the function of height. So this is x value and this is fx value. So then we move forward, as we know that Fr is nothing if we reduce it in the form of pressure. It will be equals to the width, and we integrate the pressure with respect to the height. So this equation becomes also equals to the P is equals to specific weight and dH. We can rearrange it in this form as well. So we need to determine the integration form of a specific weight with respect to the height. For that, what I have done, this is the x value, these are the specific weight values, fx values. These are the average values of a specific weight in a manner that if I am moving at 0, I have took the average of this point only. If I am height 0.4, so I took the average of these 2 points, and when I will move in third part, this is the average of all these three values. This is the average of all four values. This is the average of all five values. In such manner, I have solved the averages of all these values. And then I multiply the height with these average specific weights in order to determine the exact pressure at a particular point of the tank, okay, and I'm getting the respective result. After determining the p values, okay, what I have to do is I have to integrate p with respect to dh, where x is h and fx is, or f value is p. So these are the p values. I multiply them with the coefficient in such a manner that this multiply with 1, 3, 3, 2, 3, 3, 2, 3, 3, 2, as it was mentioned here, that f should be multiplied in such a manner that f naught value will be multiplied with 1 coefficient, then we have a series of 3, 3, 2, 3, 3, 2, 3, 3, 2, and end with 1. And I done this in similar manner. Then I took the sum of all these values. Okay, so what terms I have covered? The summation of all these f I have done. Okay, I need to determine the value of h, and h value is equals to xn minus x naught divided by n, and n is equals to 9. We have discussed in previously. So we calculate h as 0.4, and we know the width is 6 as it is described here. The vertical tank of the vertical wall of the tank, that is 6 meter wide. So we know all these value, b value, and integral of all these. For integrating these factors, I just need to do the similar formula, 3/8 multiply the h value. The h value is here, and then we have the summation of all these values, which is here, sum. So the integral will be equals to this. After that, I just multiply 71.2 with 6. Okay, the width according to the formula, 71.22 multiply by 6. So I come up with the answer of 427.32. So which is the value of FR? I don't know why I represent these values. Anyway, only the upper part of the equation is utilized in order to resolve this numerical. Then we resolve it with movement form. Okay, FR YR is equals to B, then HP product, and we have to integrate it with respect to the H. So solving first this integration form, the x value is again H, and fx value is HP, the product of H and P. So firstly what we have done is we took the products of respective positions and we determined these values. And again we have to utilize in such a manner that the coefficient should be added with 1, 332, 332, 332 series, and end up with 1. Similar work I have done here and got the summation of that. And in similar way I determined the value of h. The integral part will be equals to 173.594431 by this formula, 3 divided by 8 multiplied by h and all sum. Then I have to just multiply it with the b value and divide it by fr value. By doing that, I can easily determine what is the value of or the position of resultant force. So this is again a numerical in which we understand that how we can resolve how complex it if the case in which the specific weight may vary from position to position, and how simplify how easy it is when the specific weight is constant. So that's all for today. I hope you can understand all the parts of this lecture. If you have certain queries, we will discuss it in the live sessions. So thank you very much for bearing me such time, and from my side, Fi Amanullah.